Hello, algebra students. We're looking at section 5.3 today, which is on factoring out the greatest common factor. So this is actually a review because we did this in chapter 4 already. But when dealing with polynomials, this is something that you have to be able to do. So we're just going to take a look at it again and do a little bit of practice. So the problems we look at are here. It says factor out the greatest common factor from each expression. So let's look at the first one. So we're going to factor out a number if there is some number that will factor out of each of those terms, and also variables. So look at the number first. We just need the largest number that divides into 36, 81, and 18. So the place to start is to, or one place to start at least, is to look at those numbers, and specifically the smallest one. That's a candidate for greatest common factor because the smallest number will divide into itself, and also it's possible it will divide into the others. If it does, then that's the greatest common factor. So I look at 18 and we say, well, yeah, 18 divides into 36, but it does not divide into 81. So since that doesn't work, we just start looking at other factors of 18. Specifically, we can just look at the factors of that smallest number, 18, and just try them. And we might as well start at the largest factor. So 18, 9 times 2 is 18, so 9 is the largest factor other than 18 itself. So we want to see if that works. We know 18 doesn't. If 9 works, it will be the greatest common factor. And 9 does divide into all of those, so we now have the number part of the greatest common factor, and that is 9. Now we look at the variables, and for each variable, the term, what we're looking for is what's the smallest exponent that variable has, okay, in any of the terms. And so let's look at the x. In the first term, it's x squared. And the next one, it's just x. Just x to the first and x to the fifth. So the smallest is this x to the first. Okay, right there. So that's the one. As far as the x variable goes, we have x to the first power, because when we look at all the terms, that was the smallest power of x that we found. Okay, so now we just have to look at y. We have y to the fourth, we have y squared, we have y squared. Y squared is the smallest. So that's what is factored out, okay, as part of our greatest common factor. So now that is the greatest common factor, and now we're supposed to factor that out. So we'll just write this down. 9xy squared factored out, and see what is left in the polynomial. So we could write down under each of these this 9xy squared to divide by it to see what goes in to here in the parentheses, okay? But we will divide by it, but I don't think we have to actually write it down under each of those. So we will just look at it and divide. So we have 36 x squared y to the fourth, our first term, and we're dividing that by 9xy squared. So we take the number part, the 36 divided by 9, that's 4. We look at x squared divided by x. Remember how to divide, what to do with the exponents when you divide. Well, x squared divided by x, subtract the exponent, right? So 2 minus 1 is 1. And then y, we look at y. We remember we're taking this whole term, dividing it by that. So y to the fourth divided by y squared. Subtract exponents, and that's y squared. Okay, so we have 4xy squared for that first term, after we factor out our greatest common factor. Okay, so let's look at the next one. Well, we can look at the number, factor out the 9 from 81, and that leaves 9. 81 divided by 9 is 9. So look at the x's. Oh, x divided by x. Okay, that's just 1, or the x goes away, cancels out when we divide that. So we've factored out the only x is one way I would look at it. Because we have x out here, and this term only has one x in it. We've factored that out. So now y squared. Oh, the same thing happens here. This term has y squared right there. And we take that divided by the y squared, that's our greatest common factor. And that's 1 as well. So we just we don't have to write down, of course, 1. We just leave that out. So it has one more term. So we divide this last one by that. Okay. So the 18 divided by the 9, that's 2. This should be negative, though. This is going to be negative because that's negative. So we have the 2, 18 divided by 9 is 2. X to the fifth divided by x, subtract exponents, right? 5 minus 1, that's 4. So we have x to the fourth. And then we have one more. Y squared divided by y squared. Well, that's 1. Okay? So I'm just going to move over the parentheses here a little bit. And there we have it. We factored out the greatest common factor. Okay, one more example. What's the greatest common factor of this next polynomial? Well, we look at the numbers first. We have 12, we have 60, negative 36. 12 is the smallest of those. So if we get any smaller than that, we won't be able to, I should say it this way. If we get any smaller, then if we try one that's smaller first, we might miss that 12 is actually the greatest common factor. Okay, so we have to try it. Might not work in all of them, but we have to try it. And 12 actually does divide into all three. So 12, as far as the number part, we have 12. And then we look at the variables. So just look at each variable and find the smallest exponent for that variable has in any of the terms. So n is raised to the fifth. It's also raised to the fourth, and it's raised to the sixth. The smallest is the fourth. So n to the fourth is right there. We write it down next to 12. That's part of our greatest common factor. And now we look at m. And we have the smallest, let's see. Oh, I see. I actually intended this to be m right here. So let me fix that. Oh, I should use black here. Let's see if we can. Okay, not too bad. So let's look at m. We have m to the fifth, and m to the fifth, and m to the sixth. So the smallest is m to the fifth, right? Okay, so we write that down here as well. Okay, and actually, if I had that written down correctly, I would have had m first. So I'm going to reverse the order of those. Usually we put them in alphabetical order. It's not a big deal. However, it's pretty easy to change that. So we want m to the fifth first, and then n to the fourth. Okay. So that's the greatest common factor. 12 goes into all three numbers, all three terms, I mean, and then when we look at the exponents, 5 is the smallest exponent on the m anywhere. So m to the fifth is in our greatest common factor. And when we look at n, we have n to the fourth. Well, turns out, oh wait, n cubed. Oh, I made a mistake. It should be n cubed. Glad I checked that. That's the smallest exponent, is actually n to the third power. You guys caught that already, right? But I did not till now. Okay. Let's see here. Okay, so should be n to the third power. And that's, we would have really messed it up when we went to factor that out. Actually, we probably would have caught it at that point. So we think this is the greatest common factor, 12 m to the fifth n cubed. So now we want to factor that out. Just write it down like this. And then write the parentheses, and we write down the terms, what's left after we factor that out. So look at the first term, and well, you factor out everything, right? When you factor out 12, there's no number left. Factor out m to the fifth and n cubed, and that's the only thing left is 1. Okay, we factored everything else out. Okay, look at the next one. 12 goes into 65 times, so we get 5 here. Okay, look at the m. We divide 60 m to the 60 m to the fifth n to the fourth by that, and the m to the fifth cancel, or think of it as subtracting exponents. 5 minus 5 is 0. So it would be m to the 0. Well, we know m to the 0 is 1, remember? So there's no m. Let's see. There's no m's left, but when we look at n to the at the n, it's n to the fourth, and we're dividing by n cubed, so we will have n left over. And So that's it for that term. So last one. Okay, we're taking this divided by this. So negative 36 divided by 12, the number part, that's negative 3 minus 3. And then we just have to look at m and n. So we have m to the 6th divided by m to the 5th. So all we have left is just m. And then we have n to the 6th divided by n cubed, and that leaves n cubed. Okay, so that's it. And we can check that by multiplying each term, right? Or multiplying by each term. Let's go ahead and do that down below. Won't take very long. So 12m to the 5th times n cubed times 1 is obviously just 12m to the 5th n cubed. Okay, and that's what we should get. We'll check it as we go along. We should get that. Okay, so now we take this times 5n. That gives us 60. 5 times the 12 is 60. M to the 5th power just stays the same. And then n cubed times n, well, that's n to the 4th. Okay. So the last one, it will be negative. Oh, wait, let's see. 36. Yeah. We're going to take 12m to the 5th times negative 3m n cubed. So that's how we know it's negative, because it's a positive times a negative. Okay, so 12 times negative 3, that's 36. Then m to the 5th times m, that's m to the 6th. And n cubed times n cubed, that's n to the 6th. Okay, so now let's check that term by term. Is this that we just did as a check, is it really the same as that original expression? And compare it term by term. Looks like it is. So, and remember, that's just the check to make sure that when you multiply it out like that, you should get back to the original polynomial. Okay, so that's all. I'll see you guys later.